Okay, so Leetcode practice time for today. 2049. Sorry, 1249. Minimum remove to make a valid parenthesis. So two things to care about in this question. Find the solution for this specific problem. The other thing is to see how to behave in an interview given this specific question. So first of all, after given the question, we need to understand it, and of course we need to clarify by asking some questions if there is anything that is unclear. This is the communication part, and also at the same time we need to think about some edge cases to make sure that the next step when finding a solution covers pretty much everything. So let's take a look at this example. So given a string of the open parentheses and the closing parentheses and lower English letters, your task is to remove the minimum number of parentheses, the open or closing ones in any position so that the resulting parentheses string is valid and return any valid string. Sure, return any valid string. What does it mean? Does it mean that there could be more than one answer? So for example, formally, a parenthesis string is valid if and only if it's empty string, of course, and it can be written as AB. So where A and B are valid strings. Okay, so if it is string containing no parentheses, or it can be written as an open parentheses A and closing parentheses. Okay, so where A is a valid string. Okay, so I think now I understand what the problem is. And the constraints for this problem is length is smaller or equal to 10 to the power of 5. And of course it's not empty. Okay, so it's not empty. So an SI is only one of open or closing parentheses or any lowercase English letters. Alright, so let's see which company is asking this. Okay, Facebook is the top one. Alright, so how to see this? It has a bold word which is return any valid string. But is it really possible that we have multiple things? Okay, so of course it is. It's okay. So any means you can just return one of it. You don't need to care about if there are more than one answer, you just return any one of them. Okay, so that would make this problem easier. So now we understand the problem. So the question is to remove the invalid parentheses from the input string. If there are more than one answer, return any one is fine. And also for the edge cases, it says constraints means there's no empty input string, and it's only contained by lowercase alphabet and also the open and closing parentheses. So now we have clarified the question. Let's step into the next part, which is about finding the solution for it. So this one reminds me of using the stack to solve this problem. So what we could do is use a stack. So the stack is to keep track of the position of parentheses. So let's go through the first one as an example. So first of all, we see L. So it's not a parenthesis, we don't need to worry about it. And then we see E, and E, so on and so forth. So the first parenthesis we encounter is a open parenthesis. So we encounter a open parenthesis, we need to find the closing one for it. So first of all, we are going to put it into the stack. So now the stack contains the one parenthesis, which is at the position 1, 2, 3, which has position 3. And then T we don't need to care about it. And then another open parenthesis with index as 5, we put it into the parentheses. So the rule of thumb is whenever we encounter the open parenthesis, we just put it into a stack. We just put the position into the stack. And then after the C, we encounter closing parentheses. So that's the time we find the matching closing parentheses for a previous open parenthesis. So when we encounter a closing parenthesis, we see whether the stack is empty. If it's not empty, we just pop the top element from the stack, because we have already found a closing one, which is a matching one for that. If the stack is not empty, I would say that's an invalid closing parenthesis, which we definitely need to put it into our stack. Let's see. So the next one is O. We just pass it, and then it's another closing parenthesis. We just pop the top element from the stack, and then D, E. The final thing is closing parenthesis, which is not valid. So I would say this one is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11. And we only have one thing. So this is the first pass. So the first pass, we find which first pass. So in the first pass, we find at which position that contains invalid parentheses we need to remove. So the next pass, so in the second pass, we are just going to use a string builder to format a string that leave the invalid position, the character in the invalid position out. So in here, I think we also need another data structure, because when we form the string builder, we definitely need to know which position contains invalid parentheses. So it would be faster if we can use use O1 lookup. So let's say we have a set of the integer, which pretty much is the same as the number contained in the stack finally. So that would be pretty much it. So let's get started and do some coding work. Oh, okay. So by the way, the time complexity is gonna be linear, because we only do 2 passes through the input array. So it's gonna be O log n. So space-wise, since we use a string builder and also the stack, so it is also going to be linear to the input. So next part is about coding. So after we agree the solution with our interviewer, having a nice and friendly discussion with him, talking about all the things, and also do the time and space complexity analysis, the coding part is about whether we are good enough to turn our idea into solid code. So in this part, we care about your code correctness and your code readability. So let's get started. So the first one is to define a stack. So stack of integers. Let's just call it stack. Okay, so the first pass is to find the invalid position. So for I is equal to 0, I is smaller than s dot plus I. So if s dot car at I is equal to a open parenthesis, then that's the time we need to put it into the stack. Then stack dot add I, and if s dot car this should be else if .car at I is equal to a closing parenthesis. The first thing we need to check whether there is the stack is empty. So if the stack is empty, then that's the time we need to put it into the stack because it's a invalid parenthesis. So we need to stack dot add I as well. Empty. Okay, empty. Sorry, there's a typo. So otherwise, if it is not empty, what we need to do is we just pull. I think it's just pop. Okay, we just pop the top element from it, and that's the first pass of the string. And the next thing is alright. So okay. So now we have the invalid element to be ready in the stack. So the next thing is to put it into a set. So set of integer invalid index. So let's say new hash set. Alright, so now we would go through the stack. We would just use a while for the while loop. Okay, so while stack is not empty, we would just keep copying the top element from it and insert it into the set. It is invalid index dot add stack dot pop. Okay, now we have finished formatting the set. It's the time we do the second pass through the input string and format a string builder. So the string builder, let's call it temp result. Is start with new string builder. Int I is equal to 0 and smaller than s.length. This was I. So if the invalid index dot contains, if it doesn't contain, so it is contains if it doesn't contain the corresponding index, then it means it is something we definitely need to put into the final string builder. So let's say temp array dot append s dot car at I. Okay, and finally we just return the temp dot to string. So that's pretty much it for the code. So let's do some, after we finish the code, it's the time we do some testing. So first of all, we are going to go through a test case to see whether it is good enough for this piece of code. Let's use the second example actually. So first it is A, so it's not we are just going to simply pass it in this for loop. So because it's not an open parenthesis or a closing one, so when we encounter a closing parenthesis, because the stack is empty, then we will add the corresponding index. So now actually let's say, so the stack now contains index as 1, and then it's B, ignore it, and C, and an open parenthesis, we put the 0 1 2 3, we put 3 into the stack, and C, encounter C, we ignore it, and when we encounter closing parenthesis, just pop up the first one into it. Okay, so I think there might be some issue, because when we encounter the closing parentheses in this piece of code, so there is a bug. So when we encounter the closing parentheses, if the top element, if there's something, let's say in this case, if it is a closing and B and closing, let's say just a closing. So because the closing thing is invalid, and we put it into our stack, we have one into the stack. When we encounter the third element, which is another closing parenthesis, we just pop it from the stack, which is not right here. So how to solve it? Okay, so I think just saying if it is empty is not enough. So when you encounter a closing parenthesis, we need to definitely see whether the top element, the top element in the stack is a closing parenthesis or a open parenthesis. If it's an open parenthesis, that's good enough for us to remove the top element from the stack. Otherwise, we just keep pushing. We just push it. So if it is stack or stack, so it is s.car at s.peak. It's stack.peak. If it's equal to a closing parenthesis. If it's equal to closing parentheses, then we keep inserting the closing parenthesis, which is invalid, into the stack. Okay. Now I think we should be good. Let's go through the test case again. So I think for the previous piece, before we change, the second example is going to pass. Let's see the third example. Let's say if it's closing and open. So if it's closing, first of all, we are going to, the stack is empty, then we just insert 0 into the stack. And then another closing, because it is, the top one is not open, so it's not open. Then we are going to add 1 into it, and then we encounter open one, we just put 2, we just keep pushing the index into it, so on and so forth. And finally, all the things are invalid, then we need to return an empty string for it. Alright, so I think that should work. Let's give it a shot. Okay, compile arrow. This is a typo. Alright, so let's submit it and see whether it will work. Okay, so it's success, which means we are good with this piece of code. Regarding the testing, after we do sanity check, we need to set up the test cases to increase the test coverage. So the system has done a pretty good job. This website has done a good job for setting up the test cases that cover different branches. But in the interview, we need to do it manually. Let's say, first of all, I would say example 1 is a very good one, and example 2 and 3 to catch the different if branches, definitely to cover all of them. Otherwise, like what we encountered, it is a bug into the string. If we just set up example 2, I'm pretty sure that example 2 or example 1, I'm pretty sure we cannot catch that case. We cannot catch that bug. We definitely need something like example 3. So other than that, I think we are good enough for this question. I hope you enjoy this video and learn maybe something from this video. I think it's a pretty normal thinking process during an interview and how to behave during the interview if it is the first time you have encountered this coding question in the interview. Yeah, so I hope you like it. If you like it, please subscribe to this channel, and I'll see you next time. Thanks for watching.